All right, guys. So in this lesson, we're going to be talking about the recursive formula for sequences. So we're going to talk about the recursive formula for arithmetic sequences and then move on to discrete sequences and the Fibonacci sequence. So the first question that should be going through your mind right now is, what is the recursive formula? We already talked about a formula in the past. We talked about the arithmetic explicit formula, but we have not yet talked about what the recursive formula is or what it looks like. So that one is a little bit different than what you're used to. So the recursive formula for sequences, or for an arithmetic sequence looks something like this. So we have Fn is equal to Fn minus 1 plus D. This is called the recursive formula for a reason. It actually relates a current term to a previous term that just passed. So what does Fn and Fn minus 1 mean? So this means the present term. This means the previous term. And this, as you already know, is the common difference. So we have the present term is equal to the previous term plus the common difference. This is for an arithmetic sequence. So I'm going to write here, because it may not be the same for the other ones. All right, so for an arithmetic sequence, Fn is equal to Fn minus 1 plus D. So what does that mean? That means that the present term is equal to the previous term plus the common difference. So el término presente es el término anterior más la diferencia común. Eso significa la fórmula recursiva para las secuencias aritméticas. So let's give you some examples and you'll see why this formula does make sense. So this basically relates sequences. Some of them are not actually arithmetic but there is a pattern, so it allows us to basically figure out how do we relate the pattern within each other for additional sequences besides arithmetic ones. So example number 1. Oops. For this example, we're going to find a couple of things for an arithmetic sequence. We're going to find the nth term formula. And the recursive formula. For the arithmetic sequence. So the nth term formula is also known sometimes as the explicit formula. But if we want a formula, we don't want to plug an n, if you remember what we talked about last time. All right, so the first one we already did in the past. The next one we haven't done at all. So we have the formula, the explicit formula that we talked about in the past, and the recursive formula that we haven't talked about yet. Let me differentiate these two. So the explicit formula, I'm going to put a little box to show where it goes. This one should be reviewed because we have talked about this one in the past, right? So this one we did in class in one of the previous lessons. The recursive formula right here, this one is new, and we're going to talk about that afterwards. We're going to see how each one relates to each other. All right, so each one is going to go in its own little box. So the explicit formula looks like this. So Fn is equal to F1 plus D multiplied by n minus 1. We've been doing that over and over and over again. This is called the explicit formula. And it relates the pattern for an arithmetic sequence. All right, it says that any term is equal to the first term plus the common difference multiplied by n minus 1. We've talked about this, right? So if we have a pattern, which I didn't even give you the pattern yet. So let's actually put a pattern down to be able to do this example. So the pattern that we're going to have here is going to be the numbers 14, then 11, then 8, then 5, then 2, and it's going to keep on going over and over and over again, right? So from this, we know a couple of things. We know the first term, which we did in the last lesson, right? So the first term is 14. We could also figure out the common difference, what we're subtracting each time. And as we can see, we actually are subtracting 3 each time to get from one number to the next. So D equals -3. So using those two values, we can basically plug in these two numbers to figure out the formula. Again, we want the formula, so we don't want to plug in anything for n, right? So we plug in these two and we simplify and we're done. So Fn is equal to F1, which is 14, plus the common difference, which is -3, multiplied by n minus 1. So we plugged in the first number, we plugged in the common difference, and we don't plug in anything for n because we want a formula. So simplify, and we get that the nth term explicit formula would be 14 minus 3n due to the distributive property. This will be +3. Combine like terms, I get that the formula should be equal to 14 plus 3, which is 17, minus 3n, or if you want to write it as -3n first, -3n plus 17, where the 17 came from the combination of the 14 with the 3. All right, so that is the explicit formula. We've done this in the last lesson that we talked about last week. Okay. Today, we're going to be talking about the recursive formula. So the recursive formula relates the present term with the previous term and the common difference. So let me show you what this means. So right now, with this formula given, 14 is the first number, right? The next number is 11, and 11 is basically the 14 minus 3. So we say that the present term 11 is equal to the previous term, which is 14, subtract 3. The next term, which is 8, the number 8 is the number that came before it, minus 3. So 11 minus 3. The number 5 is the number that came before it, minus 3. The number 2 is the number that came before it, minus 3. So every single number is a number that came before it, subtracted by 3. Okay, so cada número es igual al número anterior, restándole 3. So this is basically what we put for the recursive formula. The recursive formula relates the numbers, the current number to the number that came before it. And this part is never going to change. So the current number, or the present number, is equal to the previous number minus 3. So we're going to put a minus 3 right next to this. And this is my recursive formula. So la fórmula recursiva relaciona el número presente con el número anterior, el que acaba de pasar. So el número presente es el número anterior menos 3. So the recursive formula is the present term is equal to the previous term minus 3. All right, so that's pretty much it as far as the recursive formula goes. So let's do one more example for arithmetic sequences, and then we'll move on to other types of sequences and where this is better applied. All right, so example number 2. Will I have enough space here? Yeah, I think I can fit it in there. So example 2, find the nth term formula and the recursive formula for the sequence that I'm about to give you. The next sequence that I will give you this time, let's get 17, 19, 21, etc. So 17 is the first number, 19 is the next one, 21, 23, 25, ... forever and ever and ever and ever and ever. This one is an arithmetic sequence. How do we know that? Because if we look at the pattern, every single time to get from one number to the next number, I add the same amount. That number that I add is 2, right? So the common difference for this particular pattern, D is equal to +2. Okay? So D equals +2. We know that by looking at the pattern. We're adding 2 each time. The first number that I have here is 17. So we also know by looking at the pattern that F1 is equal to 17. What we need to do now is find the formulas that they want. So the first formula that they want is the explicit formula in terms of n, which I will put on one side, and the recursive formula in terms of n and n minus 1. All right, I hope that's enough space. So I'll put one in each box. So the explicit formula will go on the blue box, and the recursive formula will go on the red box. So the blue box, we've done this before, right? So this is just going to be a little review for you. So the blue box, the recursive formula, the explicit formula will be Fn is equal to F1, which is the first term, plus D multiplied by n minus 1. All right, where D is known and the first number is also known. So we can plug in these numbers, right? We know the first number is 17. We know the common difference is equal to positive 2. We don't plug anything in for n because we want a formula, so we leave it alone. So then Fn, any term, is equal to the first term, which is 17, plus D, the common difference, which is going to be positive 2, multiplied by n minus 1. Simplify this, we do the distributive property, so f of n is now equal to 17 plus 2n minus 2, and then combine like terms. Again, we can combine the 17 with the negative 2. 17 minus 2 is equal to 15. So we get the final formula, Fn is equal to 2n positive 15, or plus 15. And then where the 15 came from the combination of the 17 and the minus 2. All right, so the left-hand side, we have the explicit formula. Let me write it sideways. And now we want to find the recursive formula. Again, the recursive formula for an arithmetic sequence doesn't really change. We have to relate the present term with the one that came before it. So we want to figure out what is the relation between those two terms. So we know that the present term, Fn, is equal to the one that came before it, Fn minus 1. But then what do we do after that? So if we look at the pattern, the D is plus D. So in this particular example, what we do with this pattern is add 2 each time. So we know that it's going to be the current term is equal to the one that came before it plus 2. All right, and that's it. This is called the recursive formula. So we're done after this step. If you want to be fancy and box your answer, you could do that. So the explicit one looks like this. F of n equals 2n plus 15. The recursive one looks more like this. Fn equals Fn minus 1 plus 2. Okay, so this right one, like I said, is called the recursive formula. It is called the recursive formula because it relates the numbers to other numbers that came before it. Why do we care? So every now and then, mathematicians found out that there are actually sequences that are not recursive and non-geometric, which we'll talk about in the next lesson what that means. But basically non-recursive, non-arithmetic, I should say, meaning that we don't add the same thing over and over again to get the next number and the next number and the next number, or subtract the same thing over and over again to get the next number, the next number, and the next number. So the patterns are a little bit harder to find. All right, so in these next examples that I will show you, we're going to actually find that there are patterns within the numbers, but the patterns are not inherently known right away. So in order for us to be able to figure out these patterns, we need to relate numbers to other numbers within that sequence. So the next example, it is called the Fibonacci sequence, and I challenge you guys to try to see if you can figure it out. So find the recursive formula for the Fibonacci sequence. Fibonacci was a famous mathematician from back in the day, famous Italian mathematicians, and basically he's the one that, well, a lot of math work, but he's famous. One of the things he's famous for is for this particular sequence right here, which he did theorizing bunnies. But anyways, the point is, this is the sequence, and I challenge you guys to try to find out what is the pattern here. And my hint to you is that there actually is a pattern. So there is a pattern here. The question is, what is the pattern? How do we get from one number to the next number? I'll give you guys a minute to think about that on your own, and then we'll go over it. Anybody got any guesses?
Yes.
What is the pattern?
Bueno, primero añadimos 0 más 1 nos da el número que es 1. Después 1 más 1 nos da el cuarto, que es 2. 1 más 2 nos da 3, que es el quinto, y así sucesivamente.
Oh, Marcela. Muy bien, muy bien. La agarraste muy rápido. That was amazingly fast. So a lot of my other classes did not get it that fast. So she figured out the pattern. So the pattern is the following. So what you need to do is you add the two numbers together that came before it to get the next number. So 0 plus 1 gave me 1, and that is the next number. If I add up the next two numbers, 1 plus 1, I get the next number, which is 2. If I add up the next two numbers, 1 plus 2, I get the next number, which is 3. If I add up the next two numbers, 2 plus 3, then I get the next number, which is 5. If I add up the next two numbers, you get the idea. 3 plus 5 gave me 8, and I can add up the next two. 5 plus 8 gave me 13. So we add up the two numbers that came before it to be able to get the next number. So how do we say that in math? And that's basically what the recursive formula comes into play. So se suman los dos números anteriores para agarrar el próximo número. La pregunta es, ¿cómo decimos eso en matemáticas? So we already know what the recursive formula kind of looks like, right? So the recursive formula looks like this. Fn, that's the current number. We want to say that we want to add the two numbers that came before it. So the one that came before Fn is Fn minus 1, because that's the one before that one, right? So how would I say two numbers before that? What would I write? ¿Cómo decimos dos números antes en lugar de uno? So just to give you a little hint, this is the present term. This is one before present. And we want to say, we have to add the second one too, right? Two before present. So how do we say that?
2n.
2n. So así. So would this be correct? Because remember, this means multiplication, right? So we don't want to multiply it, because that means that we're gonna get way off from where we actually want to be. We just want to be two spaces back.
Is it plus 2?
Plus 2, that means we want to go two spaces forward. So, oops, what did I press? Sorry about that. So if I do plus 2, then you're saying this basically. If I do n plus 2, we would say that this number is equal to, let's say, for example, this one is equal to this one, the one that came before it, plus this one, which is not true, right? Because this is Fn. This is Fn minus 1. And this one right here would be Fn plus 2, which is 2 after. So we don't want to say 2 after, we want to say 2 before.
Entonces es n menos 2.
N menos 2, right? We want to say Fn minus 2 because we want to say 2 before. 2 spaces before, not 2 spaces after. So los espacios tienen que ser antes, no después. So that would mean that we don't take the 5 into consideration. We just take the one before it, which is Fn minus 1, and then 2 spaces before it, which is n minus 2. So that means that we're adding these two to get the next one. So Fn, which is the present term, is equal to the one before it plus the one before that. So that's it. This is the Fibonacci sequence. And you've got it surprisingly very, very fast. So thank you very much, Marcela. Good job to you. Sí, tienes razón. So básicamente esa es la fórmula recursiva de la secuencia. Y noten de que la secuencia no es aritmética. So notice that this sequence is not arithmetic, right? So we're basically, there is a pattern, but how do we identify this pattern without, with a formula, without actually like saying exactly the explicit formula, because it's not explicitly arithmetic. All right, and this would be the way to do that recursively. So this is why the recursive formula is useful. All right, so esta es la razón por la que la fórmula recursiva es usada, porque podemos encontrar relación entre números que tienen un parentesco sin necesariamente tener que hacer una fórmula explícita aritmética. So two more. Let's see if you guys can figure this out. So let's make it a little bit harder on you. These ones are called discrete formulas. So this is not the Fibonacci sequence anymore, but these are called discrete formulas because there is a pattern within these formulas. That is a combination of whatever may be happening within these numbers. So find the recursive formula for the discrete sequence. Now this next discrete sequence that I will give you is the following. So we're going to have 7. The next number is 20. The next number is 59. The next number is 176. The next number is 527. And it keeps on going over and over and over again. Again, my hint to you is that there is a pattern here. The question is, what is that pattern? So we're trying to figure that out. This one's a little harder. So the best thing we can do here is just try to guess and check to see what's going on. All right, so let's start like guessing. So let's say, for example, we get this first number 7. If we take 7 and we try to do, okay, let's pretend that this is arithmetic and try to check that, it doesn't work, right? If we do 7 to the 20, we have to add 13. But then if we add 13 to this, then we do not get 59, so it's not arithmetic. So we have to try something else. So if we think, let's say, for example, multiplying by 2. So 7, let's take 7 and multiply it by 2, right? So times 2. Now we have 14, and we want 20 for the next one, so we're not done there. Let's take multiply by 2, and now let's add 6 to see what happens. So that gives me 20 for the first one, for the next term, which is okay. Now let's see if it works for the next one. So now we're going to take 20, multiply by 2, which we get 40 now. And now we're going to add 6 to that, and we get 46. But the next one should be 59, so that doesn't work. No good. So we have to try something else. Let's say we multiply 7 by 3 now. So 7 times 3, we get 21. But we don't want 21, we want 20. So we're going to take that number and then subtract 1. See what that gives me. So that gives me 20. So that works out for the next one. Let's check the next term. So we take 20, which is the next term, and then I multiply it by 3. Now I have 60, and then I subtract 1, and then I get 59. So that works out for the next one. Let's see if it works out for the next. So 59 times 3. I don't know what that is. Let's see, 6 times 3 is 18, 180, 177. Yeah, 177, and then minus 1. We get 176. So it does work out. If you look at it, it actually does follow the pattern. So let's write that mathematically, okay? So we want to say, with the recursive formula, we say that the current term, Fn, is equal to the one that came before it times 3, right? So 3 times that. But then after that, we have to subtract 1. So the recursive formula will look like this. The present term is equal to the one that came before it times 3 minus 1. Right? So el término presente es el término anterior multiplicado por 3 menos 1. So where Fn is the present term, and then n minus 1 would be the previous term. So el presente y el término previo. Cool. You guys are getting better at this. One more example for you guys, and I think that is it, since you guys are kicking butt at it. Example number 5. I have another discrete. Do I have 1 or 2? I may have 2. Let me see. Oh, yeah, I do. What a drag. 2 more, but we're almost done with this. So the next one, example number 5, same thing. We have a discrete sequence. That discrete sequence is going to be equal to the number 5, then the number 15, then the number 35, then the number 75, then the number 155, and it keeps on going over and over again. Again, it looks like there's no pattern here, but I guarantee you there is a pattern. So if you think that it's adding 10 each time, that is not the case, right? Because if you add 10 to this should give you 25, not 35. So it's not arithmetic. So it's definitely something else, though. Esa secuencia no es aritmética, pero sí tiene un parentesco. Hay algo que está pasando cada vez. So let's try something else. Let's say the first number is 5. Let's multiply it by something. Let's say 2. See what we get. So if I multiply 5 times 2, I get 10, but I don't want 10, I want 15. So now let's add 5 to that and see if that pattern works out. So 10 plus 5, that would give me 15. So let's check it for the next ones. So now between the 15 and the 35, let's see if that works. So 15, we multiply that by 2. For that one, we get 30. And let's say what happens if we add 5 to that. So if we add 5 to that, we get now 35. So that does work out so far. Let's check it one last time. 35 times 2. That would give me 70. And then if we add 5 to that, we get 75. And that's exactly what we have in our pattern, right? So it actually does work out. So on the first try, I actually got the recursive formula. We just got to plug it into the formula so we can say this, right? So we're going to say that the current term is equal to the one that came before it, or the previous term, multiplied by 2. So let's have a little bit of space for that. So fn minus 1 multiplied by 2. So it's going to be 2 times that. And then we have to add 5 to that. So plus 5. So this would be my recursive formula for this particular sequence. And again, it is not arithmetic because we're not adding the same thing over and over again. But we can find a pattern. This is called the discrete sequence. So this is the present term. And this is the previous term, which we multiply by 2 and add 5. Okay, last one, and we'll call it a day. I'll challenge you guys to try to figure this out on your own, and then we'll go over it together. So traten de intentar a ver si pueden identificar cuál es el parentesco de la secuencia. Number is 6, should be example 6. Find the recursive formula for the discrete sequence. In this particular example, oh, and I made it hard too. See if you guys get it. So 0, 3, 6, 18, 48, 132, and it keeps on going over and over and over again. I'll give you guys about 30 seconds or close to a minute to try to figure that out. See if you guys can get it. A ver si pueden identificar qué es lo que está pasando aquí. Okay, you guys have struggled enough. So let me go over the answer, what it should be. I know this one's a little bit more difficult, or it's a little harder to see, but watch. So obviously it's not arithmetic, right? We can't add the same thing over and over again. So this would be plus 3, but if you add 3 to the next one, it would not work out. So it's not arithmetic. Let's see if we can multiply by something. Okay, so 0, what can I multiply to get 3? Well, I can't multiply anything to get 3. So that would not work. 3, I can multiply this by 2, right? But this 3 times 2, I would get 6 for the next one. But 6 times 2 would give me 12, not 18. So that would not work. We're not multiplying by 2 each time. So what the heck is going on? So the pattern for this is actually you take the first 2 numbers and you multiply those 2 by 2, and then you actually add them. So this would be 0 times 2, and this would be 3 times 2. And then you would add those 2 answers. So 0 times 2 would be 0. 3 times 2 would be 6. And 0 plus 6, we get the next number, which is 6. If I do the same thing with the last 2, so let's try these 2 now. We're going to try with the 3 and the 6. So we're going to take 3 times 2. And then we're going to add it to 6 times 2. 3 times 2 is going to give me 6. 6 times 2 is going to give me 12. 6 plus 12 will give me the next number, which is 18. So it's a little bit harder to see, but again, there is a pattern going on here. I can do it with the next one as well. 6 times 2, I get 12. And the next one will be 18 times 2. I get 36. So 36 plus 12. I get the next number, which is 48. So how do we say that? So we want to say that, and I'll type it in so it makes a little bit more sense. So the current term is the sum of the previous two terms multiplied by 2. So el término presente es la suma de los dos términos previos multiplicado por 2. So we just have to say that in an equation, which is what we call the recursive formula. Okay, so the current term, that would be Fn, is, so that would be equals the sum of the previous two terms. So that would be Fn minus 1. That would be the one that came before it. But then we want the other one also that came before it. And we want to add it because we say sum. Right? So that's sum of the previous two terms. So that's Fn minus 1 and Fn minus 2. So esa es la suma de los dos términos previos. And then we want to multiply that by 2. So we multiply each one of these by 2, or we can put it all in parentheses, however you want to write that down. So we can say that all this is multiplied by the number 2. Everything is multiplied by 2. Or we can write it as individually. You multiply them by 2 and then you add them up. However you want to write that, you get the same answer. So this is 2 multiplied by Fn minus 1 plus 2 multiplied by Fn minus 2. So se multiplican los dos términos previos por 2 y se suma el resultado para agarrar el término presente. All right, so there you have it. This is basically examples or many examples of recursive formulas and how we use that in mathematics. Sometimes there is a pattern that we can't inherently see that is not arithmetic, but we can still figure it out based on the relationship between one number to the next number.